Greetings everyone, I'm your tutor Kara, and today we're going to be doing questions from Euclidean geometry. These are very interesting questions, so we have a quite number of questions that we're going to be doing together. There's about 13 questions that we're going to be doing together, so I hope you guys enjoy this. So without further ado, let us just jump on these questions and start solving them. So question 1 here, it says O is the center of the circle, and then evidently we are required to find A. So this small letter A here, that's what we're trying to find. So we're going to apply the theorems that we know from Euclidean geometry. Now, when we look at this diagram here, we are given angle B or angle OBC, which is 50 degrees. Now, I want you to pay attention to this, right? OB, it's a radius, and then OC is also a radius. So these two are equal. These two are equal, right? So now let me just write it here. So this, by the way, for all the information that I'm going to be adding on the diagram, I'm going to use a red color. So all the information that was not given initially, I'm going to indicate it by a red color. So now OB is equals to OC, and the reason for this is because both of them are radius of the circle. So now we say OB is equals to OC, and then the reason for this we say equal radii. Equal radii is the reason. So now we can see that in fact on angle OCB has to be equal to angle OBC, and the reason for this is because OB is equals to OC. Therefore, OCB is equals to 50 degrees. I mean, look at this, right? The fact that this length is equals to that length, so the fact that this length is equal to that length, it makes triangle OBC to be an isosceles triangle, because we know that isosceles triangles, the base angles have to be equal. Therefore, this is supposed to be 50 degrees as well, as I've indicated there. Alright, so now that we know that, okay, this is equals to 50 degrees and this is equals to 50 degrees, we can easily calculate angle BOC. Let us go ahead and do it. So BOC so when we add angle BOC with angle OBC, so plus angle OBC plus angle OCB, they sum up to 180 degrees. And then the reason for this, we say angles in triangle sum to 180. I'm running out of space here, but I hope you understand, you get the point that I'm trying to make here. So angles in a triangle sum up to 180 degrees. That is going to be our reason for this one here. So we're looking for BOC. So BOC is going to be 180 degrees minus 2 times, because now these two angles are equal. So these two are equal, this one and this one. They are both equal to 50. As you can see, angle OBC is equal to 50 degrees. And the angle OCB is also equal to 50 degrees. So I'm going to say minus 2 times 50 degrees there. Therefore, BOC is 80 degrees. That is BOC. So now we know that, okay, this one BOC is 80 degrees. So I'm going to use the red color there, or the red ink, to indicate it. So BOC is equals to 50 degrees. Nice one. Now we're going to apply another interesting theorem here. So there's a theorem that says angle at the center is twice the angle at the circumference. So that is what we're going to apply right now. So angle at center is going to be B This is going to be BOC is going to be 2 times BAC. So the reason for this, we say angle at center is equal to 2 times angle at circumference. That is going to be our reason there. Therefore, BOC, no, we're not looking for BOC, we're looking for BAC. So BAC, therefore, BAC is equals to BOC over 2. BAC is given to us as A. So we're going to put A here. So this is going to be A is equals to BOC, we've calculated it to be 80 degrees there. So therefore we're going to put 80, substitute 80 there, we divide it by 2. And then this whole thing becomes 40 degrees. Therefore A is equals to 40 degrees. There is the final answer there. So now we can go ahead and indicate in the diagram, or we don't have to actually. So we've calculated A to be 40 degrees. Let me just erase this A here and then put the 40 degrees like that. So we're done with the question. Now we can move to the next part, to question 2. Question 2, we're given this diagram again. There's no circle here. Sorry, there's no center of the circle. So we're given just lines and chords and arcs of the circle, right? So now we are required to find E, D, yeah. So that's what we are required to find, angle E and angle D. So if you can see here, right, these angles are subtended from chord, or not a chord, but then from arc AB. All these 3 angles, because we have 3 angles here. Let me show you. We have this angle, that angle, and that angle. All these 3 angles are subtended from this arc. So you see this arc here, all of them, they're subtended from that arc. So now this simply means that we're gonna have to apply that theorem. So the theorem looks as follows, right? So angle A, E, B is equals to angle A, D, B, and then it's also equals to angle A, C, B. And the reason for this is that angles subtended from same chord, or you can just say same chord, or just say chord AB. So because of this, we know that angle ADB is D. So D is equals to angle ACB is E. Therefore this whole thing is equals to 31. D is equals to 31 degrees and E is equals to 31 degrees. So we're done solving the question, just like that.